Good afternoon friends. In this video I am going to explain about some basic formulas of integration and some important formulas and useful trigonometric substitutions and some helpful trigonometric identities. I hope these formulas will be helpful to you in solving different kinds of integration problems. So first of all, if we see this is nothing but integral sign, the symbol of integration. So this is, if we'll pronounce this as integration of f of x dx. So here this is called lower limit and this is called upper limit, but as lower limit and upper limits are not mentioned, this is called indefinite integration. So here f of x is called as integrand. This here f of x is called as integrand. F of x dx is called as element of integration, and this symbol is known as the sign of integral. So here what we are getting, the function g of x, this is called as antiderivative or primitive or integral of function f of x. Why g of x is called antiderivative or primitive? Because if we do derivative of this function, we get f of x. See, if we do derivative of this function g of x, we get f of x. So the process of finding the functions whose derivative is given is called anti-differentiation. The process of finding the function g of x whose derivative is f of x, that is known as antiderivative. Here g of x is nothing but antiderivative because this derivative is given in the question. We are asking to find the function whose derivative is f of x. So g of x is called antiderivative of function f of x. So coming to basic formulas of integration. So first formula is integration of x power n dx. So the formula is x power n plus 1 by n plus 1 plus c. Next formula is integral of 1 by x dx, which is nothing but ln or log to the base e mod x plus c. Here we can also write as log mod x to the base e plus c. We can represent by log to the base e or ln, your wish. So in later stages I will use ln. You can use log to the base e also. Now integration of e power x dx is nothing but e power x plus c, and integration of a power x dx, actually from this only this formula also came. So we will see how it is came. Integration a power x dx is nothing but a power x by ln a plus c. So a power x by ln a plus c, actual formula. So here also we can apply this e power x by ln e plus c. As ln e is 1, so e power x plus c. So like this formula is came. So integration of sin x dx is nothing but minus cos x plus c, because again if we can check in reverse manner also. In differentiation of cos x is minus sin x, and it is minus, so plus sin x. So plus sin x is present in the integral. So this is right. We can verify like that. So integration of cos x dx is sin x plus c. We can verify in reverse manner also. Differentiation of sin x is cos x. Now integration of secant square x dx. Differentiation of tan x is secant square x. So tan x plus c. So integration of cosecant square x dx. So differentiation of cot x is minus cosecant square x. So differentiation of minus cot x is cosecant square x. So minus cot x plus c. Integration of cosecant square x dx is minus cot x plus c. Integration of secant x tan x dx. Differentiation of secant x is secant x tan x. So secant x plus c. So integration of cosecant x cot x dx. So differentiation of cosecant x is minus cosecant x cot x. So answer is minus cosecant x plus c. So now coming to integration of cot x dx. So ln mod sin x plus c. Otherwise we can write as minus ln mod cosecant x plus c, because sin x is 1 by cosecant x, so cosecant x power minus 1, so minus 1 we can bring to here, so minus log mod cosecant x plus c. Similarly, integration of tan x is nothing but ln mod secant x plus c, otherwise minus ln mod cos x plus c. C is nothing but constant of integration. Integration of secant x dx. Now this is nothing but ln mod secant x plus tan x plus c. Otherwise you can also write as ln mod tan of pi by 4 plus x by 2 plus c. This integration of cosecant x dx, ln mod cosecant x minus cot x plus c. Otherwise we can write this as ln mod tan of x by 2 plus c. Now coming to some important formulas of integration. This will helpful in solving different kinds of problems. So these are very important formulas actually. Now coming to the first formula, integration of 1 by root a square minus x square dx. This is nothing but sine inverse of x by a plus c. Sine inverse of x by a plus c. Now coming to second formula, integration of 1 by x square plus a square dx. This is nothing but 1 by a tan inverse of x by a plus c. 1 by a tan inverse of x by a plus c. Now coming to the integration of 1 by x root over x square minus a square dx. This is nothing but secant inverse of x by a. So 1 by a times secant inverse of x by a plus c. Here these formulas we can convert to cos inverse also, because sin inverse x plus cos inverse x is pi by 2. So sin inverse x is nothing but pi by 2 minus cos inverse x, and pi by 2 plus c is constant anyhow. So this we can write as minus cos inverse of x by a plus c, because this we can write as pi by 2 minus cos inverse of x by a plus c, and this constant, and this is pi by 2 is also constant, so overall constant is c, and this minus cos inverse x by a. So we can write this as this also minus 1 by a cot inverse of x by a plus c. This also we can write minus 1 by a cosecant inverse of x by a plus c. So coming to this, integration of 1 by x square minus a square dx. This is nothing but ln mod x minus a by x plus a plus c. Before that 1 by 2a we have tried. 1 by 2a ln mod x minus a by x plus a plus c. Sorry, ln. Coming to integration of 1 by 1 by a square minus x square. Now coming to this formula, similarly we will write ln, but as it is a square minus x square, in numerator we will write a plus x and denominator we will write a minus x. That is the difference between this and this formula. Here also we will write 1 by 2a ln mod a plus x. Here it is a minus a square minus x square. We have to write a plus x. By in denominator we have to write a minus x plus c. So this is the formula of this one. And now coming to integration of 1 by root x square minus a square dx. Similarly, we have to write ln mod x plus this one we have to write root over x square minus a square plus c. Similarly, this also integration of 1 by root x square plus a square dx. We have to write simply ln mod x plus this one we have to write as it is root over x square plus a square plus c. This is the some of the important formulas. So how I am able to write these formulas? How these formulas got derived from this question? How this formula has evolved? So in order to solve this kind of integration and to get these answers, so we need to know some of the useful trigonometric substitutions. So by integration by substitution we solve and evaluate these integrals. So to evaluate these integrals we need to know how to solve the integration by substitution method. So in order to evaluate and solve integration by substitution, we need to know some useful trigonometric substitutions. Suppose say if you see in question like integration like 1 by x square plus a square dx. So whenever you see x square plus a square, usually we need to know some 3 trigonometric identities. Those are sin square x plus cos square x is 1, secant square x minus tan square x is 1, cosecant square x minus cot square x is 1. So if you know those 3 important identities, trigonometric identities, here x square plus a square, if we substitute x is equal to a tan theta, it will become a square tan square theta plus a square. It will become a square of 1 plus tan square theta. So in denominator it will become a square of 1 plus tan square theta. In numerator, say like formula like integration of dx by x square plus a square. So in denominator it will become a square of 1 plus tan square theta. In numerator it will become as, if we do dx by d theta here, a secant square theta d theta. In place of dx we will write a secant square theta d theta. In place of denominator we write a square of 1 plus tan square theta. If we take tan theta as t, it will become a square of 1 plus t square. See, I will explain here. Integration of, if we write dx as a secant square theta d theta by x square plus a square will become a square of 1 plus tan square theta. A square of 1 plus tan square theta. So if you take tan theta as t, it will become a dt is nothing but secant square theta d theta by a square of 1 plus t square. So this a and this a get cancelled. So we will get 1 by a, 1 integration of 1 by x square plus a square. We know that 1 by a 1 by 1 we know that integration of dt by 1 plus t square is tan inverse t. So tan inverse t is nothing but tan theta. Tan theta is nothing but x by a, tan inverse of x by a plus c. So in this way, by this x is equal to tan theta trigonometric substitution, we will able to prove this result. So similarly, if you see a square minus x square, if you put x is equal to a sine theta, then this will become a square of 1 minus sine square theta. Similarly, x square minus a square, if you see, we have to put x equal to a secant theta, because secant square theta minus tan square theta, it is 1. Secant square theta minus 1 is nothing but tan square theta. So usually if we substitute x equal to a secant theta, it will become a square of secant square theta minus 1. So basically, if you will see a minus x, then we have to put x is nothing but a sine square theta, because if you put a sine theta, there is no use, a of 1 minus sine theta. If you put a sine square theta, we can take a common, a of 1 minus sine square theta it will become. So if you see here x minus a, if we put x is equal to a secant square theta, we'll get a times secant square theta minus 1. So now here, if we see x plus a, we have to put x equal to a tan square theta, because it will become a of 1 plus tan square theta. Similarly, if you see root over a minus x by a plus x, or root over a plus x by a minus x, we have to put x is equal to a cos 2 theta, because if we put a x as a cos 2 theta, we can take a common, 1 minus cos 2 theta by 1 plus cos 2 theta. We know 1 minus cos 2 theta is nothing but 2 sin square theta. We know that if we substitute x as a cos 2 theta, a get cancelled, numerator and denominator, we get 1 minus cos 2 theta. We can by 1 plus cos 2 theta. We can simplify this as cos theta is nothing but 1 minus 2 sin square theta, or 2 cos square theta minus 1. We will able to simplify numerator and denominator like that. We know that if you substitute here cos theta is 1 minus 2 sin square theta, in numerator it will become 2 sin square theta. We substitute cos 2 theta is 2 cos square theta minus 1. Minus 1 plus 1 get cancelled. We remain with 2 cos square theta. So overall it will become tan square theta in under root. So overall it will become tan theta. Like that we will able to simplify in integration question. We know that integration of tan theta d theta already. That is nothing but ln mod secant theta plus c. So we know already that integration of tan theta d theta is nothing but ln mod secant theta plus c. So like that we will able to simplify these kind of questions by using trigonometric substitution. Now coming to integral formulas. Other integral formulas, these also may be useful in some kinds of problems. Actually this will solve by using integration by parts, but we can remember this as some standard results. Integration e power ax sin bx dx is nothing but e power ax by a square plus b square, a sin bx, so minus b cos bx. You can remember like trick, as sin x is odd function. You already know odd function, f of minus x if we substitute, we'll get minus f of x, we'll get, that is nothing but odd function. If we substitute f of minus x, and even if we after substituting a minus x in place of x, we get f of x only, then that is called as even function. So as sin x is odd function, we can remember here minus sign. As here cos x, integration of e power ax cos bx dx, as here cos x is even function, we can write this as e power ax by a square plus b square, a cos bx. As here cos x is even function, we can write this as plus b sin bx plus c. So integration of e power ax sin bx dx is nothing but e power ax by a square plus b square, a sin bx minus b cos bx plus c. Integration e power ax cos bx dx is nothing but e power ax by a square plus b square, a cos bx plus b sin bx plus c. Now coming to integration of root over x square plus x square dx. So coming to integration of root over x square plus a square dx. So this is nothing but, first we have to write, usually these three types of integral formulas we have to write starting stage x by 2 we have to put, and similar thing we have to write here as it is root over x square plus a square, we have to write root over x square plus a square. As here before this constant plus sign is there, we have to write plus a square by 2. See, a square by 2. So if this is present is denominator, say 1 by root over x square plus a square dx, we have learned that ln mod x plus root over x square plus a square plus c, that's all. Similarly here also we have to write x by 2 under root, same thing, x square minus a square minus x square. Before this constant plus is there, so I am writing plus a square by 2. If this is present in denominator, 1 by root over a square minus x square integral is sin inverse of x by a, sin inverse of x by a plus c. This is the formula. Similarly this also we have to write x by 2 under root x square minus a square. As here before constant minus is there, I am writing minus a square by 2. If this total is present in the denominator, 1 by root over x square minus a square dx, integral is ln mod x plus, this one we have to write root over x square minus a square plus c. So these are some other integral formulas and some of the helpful trigonometric identities which will be helpful in solving integration formulas. Now we'll discuss those. So some of the useful trigonometric formulas are cos 2 theta is nothing but 2 cos square theta minus 1, which is nothing but 1 minus 2 sin square theta. Also you can write as cos square theta minus sin square theta. So from this formula, cos theta is nothing but 2 cos square theta minus 1, we get cos square theta as 1 plus cos 2 theta by 2. From this formula 1 minus 2 sin square theta, we get 1 minus cos 2 theta by 2 sin square theta. So these are the important formulas which will be useful. Later we will generalize these formulas. And coming to sin 2 theta, we write as 2 sin theta cos theta. Coming to sin 3 theta, 3 sin theta minus 4 sin cube theta. From this sin cube theta we will write as 3 sin theta minus sin 3 theta by 4. So now coming to cos 3 theta, 4 cos cube theta minus 3 cos theta. So from this cos cube theta we write as 3 cos theta plus cos 3 theta by 4. See. Now if we generalize these formulas, we will get sin square nx, which is nothing but sin square theta. In place of theta here we have nx. This is nothing but 1 minus cos 2 theta by 2. 1 minus cos 2 times nx. Nx is theta I said by 2. Now coming to cos square nx. 1 plus cos 2 theta by 2. 1 plus cos 2 times nx by 2. Now coming to sin nx. Sin 2 theta is nothing but 2 sin half of that angle cos half of that angle. So sin nx is nothing but 2 times sin half of this nx by 2. So half of this nx cos of half of this nx. So 2 sin nx by 2 cos nx by 2. Coming to sin cube theta, we have 3 sin theta minus 3 sin 3 theta by 4. So 3 sin theta minus sin 3 theta by 4. In place of theta we have nx. Similarly cos cube nx is nothing but 3 cos theta plus cos 3 theta by 4. In previous formulas I have said that as sin, trick to remember this is, as sin is odd function so it is minus, as cos is even function it is plus. So like similarly you can remember these two formulas. So these are the important formulas of integration which will be helpful in solving different kinds of integration problems. In later stages we will discuss some problems related to integration by substitution method and some different methods of evaluating the integration. So thank you everyone.